Hi, it's Dr. Pitcher again, and in this lecture we'll go ahead and take a look at some reactions of alcohols. But first, another Grignard reaction. I forgot to show the Grignard, although I did show this particular version of the Grignard in the second synthesis lecture. I forgot to show the Grignard reaction using an epoxide. So if I have an epoxide and react that with RMgX followed by H3O plus, I will get R boom boom OH. So it'll be a primary alcohol 2 carbons longer. So just wanted to mention that because I had forgotten to mention that last time. All right, let's look at some reactions of alcohols. Now we've seen a bunch of reactions reactions of alcohols in previous chapters. So we'll just say here previously we've seen some reactions of alcohols. So let's see, we have conversion to alkyl halides. And let's see, if we had a tertiary alcohol, we can go ahead and do, we'll just use HCl, or we could use HBr. And so this is an SN1 reaction. If we have a secondary alcohol or primary alcohol, and we treat these with something like PBr3 or SOCl2, I should mention here, let me scribble that out there, hold on. And these are SN2 reactions here. Okay, PBr3 will replace the OH with the bromine. Sorry, there's a 3 there. And SOCl2 will replace the OH with the chloride. And either of these reactants work either on secondary or primary. Okay, so depending on what type of alcohol you have, you'd have to use a different technique to turn it into an alkyl halide. All right, now we also saw conversion to tosylates because we might need to make a good leaving group that way. Let's just do something like that. And this really could be any capital T lowercase s, TSCl. And now I will get OTS. I will get my tosylate. We've seen dehydration. Okay, and that is an elimination reaction. It's an E1 reaction. Typically best for tertiary alcohols. And so we can use H3O plus and heat. You can use it with secondary alcohols, although it is prone to rearrangement. So if I had an OH here instead, I'd potentially actually would end up getting the same product. But you do have to watch out for this as well. And then we've seen, what else have we seen? Actually, no, we haven't seen it, but a new one here is conversion to esters. And if I have my ROH and I treat it with R prime Cl, this is an acid chloride. It's a derivative of a carboxylic acid. I will get R prime O, R double bond O there. I'll get my ester. Okay. Now, some other reactions that we haven't talked about yet are the oxidation of carbonyls. Oops, sorry, oxidation of alcohols to form carbonyls. So that's another new one here. And I'm going to start out just by using this as some generic oxidizing agent. And we'll go ahead and we'll take a look at some specific oxidizing agents in a little bit. Okay, so oxidation of alcohols. Let's say we have R prime, R double prime, OH, a tertiary alcohol, and we try to oxidize that, we will get no reaction. It's just too difficult to break these carbon-carbon bonds here. Now, if I have a secondary alcohol, and I oxidize, I will get a ketone. And if I have a primary alcohol, oh my god, that is not a secondary alcohol, Wayne. I am so sorry about that, guys. Let's draw this again here. RCH, R prime, OH. There's my secondary alcohol. Oh my gosh. Alright, let's try this again. RCH, H. I was getting ahead of myself. I was thinking about the product when I drew the reactant. So we'll have some oxidizing agent here, and now we will get R, C, double bond O, H. We'll get an aldehyde. The only thing is, aldehydes can also be pretty easily oxidized into carboxylic acids. Okay, so tertiary alcohols will have no reaction under oxidation. Secondary alcohols, when you oxidize them, will make ketones. Primary alcohols, when you oxidize them, will make aldehydes or carboxylic acids, depending on how strong an oxidizing agent you have. So what are some good oxidizing agents? Well, anything that has a bunch of oxygen in it. And there are, let's see here. I'm just looking at some possibilities here. So let me sort of summarize, guys, because there's lots of things. I mean, you know, ozone will oxidize stuff. Bleach will oxidize stuff. In fact, we used to do an oxidation in Chem 12B, turning borneol into camphor, and we used bleach. You can do it with chromium-containing compounds, which are kind of nasty. But then there's another one called oxone, and you use that oxone, which is this sulfur-containing compound, a mixture of different sulfur-oxygen compounds, and you add in sodium chloride, and it actually makes chloride or chlorine that will then oxidize the alcohol, and it's pretty gentle. So let's look at some oxidizing agents. Okay, we've got Na2Cr2O7/H2SO4. That is chromic acid. And that is really harsh. That will oxidize your primary alcohol all the way to your carboxylic acid. It's also poisonous. And don't mess around with chromium stuff. That's all I can say. Okay, what else could we do? KMNO4. Hot and OH minus. And that will oxidize our primary alcohols all the way to the carboxylic acid. They'll also do the secondary alcohol oxidation, but because the secondary alcohol can't be oxidized past ketone, they stop there. Gentler oxidizing agents. So these ones are harsh. So gentler oxidizing agents include PCC, which is pyridinium chlorochromate. So it is a chromium-containing species. So these guys, but it will stop at the aldehyde. So using PCC, you'll stop at the aldehyde. That oxone that I referred to is also a gentler oxidizing agent, and it's a bit greener. And then the last one is the Des-Martin. I wrote it down wrong in my notes here. Des-Martin periodinane. So Des-Martin. This is what the text uses. I'll typically use PCC when I write problems and answers and stuff. That's because it's easy to write PCC instead of Des-Martin periodinane. What is the Des-Martin periodinane? I can't even say it. Gosh, what does it look like? Take a look at the text. So it's this more complex iodine-containing species, but it is a gentler and less toxic oxidizing agent. So gentler than these guys, less toxic than the chromic acid or the PCC. Okay, let me just write in here, pyridinium chlorochromate. All right. Whew. So that's oxidation of alcohols, some reactions of alcohols. Now, there's one more reaction of an alcohol that I want to show you. And that is formation of silyl ethers. What is a silyl ether? Well, let's look at the following here. I've got silicon. I'm going to stick 3 methyl groups on it. So this is trimethyl silyl chloride, or TMSCl. And this can undergo an SN2 reaction pretty readily because the silicon here is a lot bigger than a carbon. So even though I've got 3 substituents and the chlorine, the leaving group, on the carbon, on the silicon, the central silicon, because the silicon's bigger, it's actually more accessible to a nucleophilic attack. So I could go ahead and let's say I had now ROH. I can treat this with TMSCl. Now we'll get ROTMS. So I'll get my R group, my O, and then my Si, CH3, CH3, CH3. This is a silyl ether. And that's going to be unreactive towards many reagents. Question is, why do this? Okay, well, let's say we had the following. Let's say we had the following molecule. And let's say we wanted to make this into a Grignard. Now we can't make this into a Grignard as is. Why not? Think about that for a minute while I'm writing here. You can even pause and think about it some more. All right, now that you've thought about it, hopefully you've realized that if you make the Grignard, one molecule of this will actually react with another molecule. So the Grignard end, the MgBr end, would just pull off the hydrogen from our alcohol. So what do we need to do? TMSCl. One, two, three, four, five. 1, 2, 3, 4, 5. And now I can do Mg in ether. I've got my OTMS. 1, 2, 3, 4, 5. MgBr. And now I can go ahead and treat this with, I don't know, let's use acetaldehyde here. That'll be step 1, and ether as the solvent, and then step 2 is H3O+. And so I'll now have OTMS. Oops. 1, 2, 3, 4, 5, 6, 7, with an OH there. 1, 2, 3, 4, 5, 6, 7. And then I can remove my OTMS by using something like a fluoride ion, like lithium fluoride, and I will get now 1, 2, 3, 4, 5, 6. What did I do? I did that wrong. Sorry about that. HO. 1, 2, 3, 4, 5, 6. And now I've got I can react, and now I've got this diol here. Okay. Or you can use a tetrabutyl amine fluoride thing called TBAF. I know, more stuff to remember. Write this down on your little note card. So what I've done is I've turned my thing that I can't use in a Grignard reaction, I've turned it into something I can use. And now I can do my Grignard reaction. And we call this protection. do apologize for the phone ringing here.
Call from Pitcher Susan.
Hopefully someone else in the family will pick that up because there we go. I'll just turn the volume off. Sorry about that. I do apologize. I'm here in the office and these things happen. All right. So we call these things protecting groups. Okay, our TMS, that's a kind of protecting group. So we've got our OTMS, that's our protecting group. Okay, so remember, good chemists always use protection when they're doing synthesis. All right, so anyway, so hopefully you remember as a good chemist to use protection in the lab when doing synthesis. And in the meantime, we've seen some oxidations and then some other reactions. We started with those, seen oxidations, and then of course we have this protection of an alcohol by making the silyl ether. And we'll do more with protecting groups next semester. I'm not going to have any questions about protecting groups or questions where you have to use protecting groups on synthesis on the exam or the final, but we'll worry about it next semester. But I did want to introduce you to it. All right, so that wraps it up for the things I wanted to focus on from chapter 17. You can go ahead and read about phenols. You can read about some of the biological stuff, biological oxidation reduction. There's some pretty cool stuff in there. It's just, I feel like, you know, we're a little pressed for time, and I wanted to focus on certain things. All right, well, until next time, stay safe out there. Bye now.